All agricultural tools, but also tools that are used in the kitchen, in the workshop, and everywhere else, are based on physical principles. Here we can see the spade that is designed to break down into the ground and then lift the ground and turn it over. Because there's nothing to be carried, the spade itself is straight. So let's have a look at the problem. It's that U-shaped profile again that makes the iron of the spade itself strong enough to withstand the bending. When Martin digs into the ground, he puts pressure on the top of the spade. It's also bent, so it doesn't cut through his foot or his shoe. Now Martin hooks on the long lever, so he puts quite a lot of force on the ground. He lifts it and turns it. It turns easily in his hands. The hoe is used to dig up bits of soil and turn them over because it is also focused in the bend and the feather of the hoe, like the quill of a pen or the shaft of an arrow. It has a high profile. It is sort of elliptical. It's just to make the hoe strong in the bend. The other thing that is used is that the hoe is quite long, and when Martin pulls out, he reaches a high speed, which then, when he stops on the dirt, he converts all the momentum into braking, and therefore the force with which the hoe digs into the ground is much greater than if we just put it there and maybe just stamp on it. Like all tools, the shovel is based on several physical principles. Again, note that the shovel has several locations on which it is bent. The reason for the bend is to increase its strength. If those raised edges weren't there, the shovel would be avoided. The other interesting thing is that if there's half of the wheel, the shovel is bent. Martin, try to get some sand. Now you'll notice that the center of gravity of that weight is under the junction of Martin's arms. Because of that, the shovel is pretty stable in his hand and doesn't tip over. Now, that's the shovel, and that's all right. And here is another thing. You notice the offset is in the opposite direction to the previous one. And that's wrong here. We'll see why this is happening in a moment. So this shovel is very difficult to hold in the hand because it's not returning to Martin. Martin's hand joins under the center of gravity, so the center of gravity tends to get as low as possible. We can see several applications of mechanical principles on this fork. The profile of the fork tip is very interesting. Note that at the base it is again to the height of the rotated non-elliptical form, similar to the thorn of the rose hip or the quill of a feather. The reason for this is again to keep the tip firm in the bend. Another thing we may notice is that the handle of the fork is also bent. The reason for this is again a question of stability, so that the main weight is over the joint of the hands that hold them. Of course, the garden wheelbarrow uses a variety of physical principles, like many other tools. When Martin grabs the holder in his hand, you can see that the load is very close to the wheelbarrow, so most of the weight is carried by the wheelbarrow. Martin therefore needs much less force to carry, and he can carry a much larger load than he could carry in his hands. We should notice one other thing. The wheel has an inflatable wheel. The more inflated, the harder the wheel. The easier it is to drive because it reduces the so-called rolling resistance. It's easier to drive on hard material, on pavement, on concrete, on asphalt. When Martin drives on soft ground, it puts quite a lot of resistance. Again, that's because there's more rolling resistance.
takto klade poměrně značný odpor. Zase důvodem je větší valivý odpor.
The secateurs use several physical principles. Let's talk about at least 3 of them. Martin exerts the force of his fingers and palm on the handles, thereby exerting quite a large force, because the arm of the handles is long, while the arm on the jaws is short. This increases the force many times over and over. The jaws are on the blade exactly on time and sharply on one of them, so that the very strong force is additionally transferred to a small area, and on that small area it can cause such a stress, such a deformation, that the twig is cut off. It is exactly because there is a high profile that causes a large moment of inertia. The moment of inertia on the surface depends on the third power of the height to the first power of the width.
Právě proto, aby tam byl vysoký profil, který způsobí velký moment setrvačnosti. Moment setrvačnosti plochy závisí na třetí mocnině výšky, na první mocnině šířky.